Google Classroom to link your code.
Google Classroom.
You're going to share Google Classroom code. No?
Ah, yes, today I will share. Electric field intensity E bar. So now the E bar, that electric field intensity E bar is denoted by capital E and it is a vector quantity. So bar, that is the on the top of that letter, electric field intensity bar. So it is defined as electric field intensity. It is generally a field strength of that specific or that the field strength generated due to that positive static charge. So, and it is defined as the force per unit charge when placed in an electric field. For that specific charge, how many electric flux lines are there or force lines are there on that charge, it is measured in terms of a field strength. So E bar, the formula is F by Q, force per unit charge. And unit for measurement of this field strength is Newton per coulomb or volt per meter. Electric field intensity. It is generally the field strength. Now, when we use the formula E is equal to F by Q. So, force formula is Q1 Q2 divided by 4 pi epsilon R square AR cap. So, that Q, suppose here written Q1 Q2 divided by 4 pi epsilon R square AR cap. So 1Q and this Q going to cancel with each other. So 1Q here, Q upon 4 pi epsilon R square AR cap. And again this unit vector is represented in terms of this vector form R minus R dash, that means final point minus initial point, and the unit vector. So this is the very basic formula, force per unit charge for the electric field intensity. Now, but in case of discrete charges, discrete means number of charges are there and total E bar is equal to electric field strength due to Q1, Q2, Q3, Q4 up to n number of charges. Okay, same as the superposition theorem. So 1 upon 4 pi epsilon summation k 1 into n. But in our E bar, that is the field strength formula, only one Q is there divided by 4 pi epsilon R square. So here it is simple, Q is there and divided by R square. 4 pi epsilon is the common term divided by an unit vector. Very simple E bar formula. But this E bar electric field strength due to only the point charge. Now we will learn different types of charge distributions. Electric field due to the continuous charge distributions means, as I already told, we have point charge that is denoted by plus Q. Then line charge, that means this positive charges are placed along a line, that is distributed along line. So known as the line charge. Then open surface, that is the surface charge. Again the charges are distributed along the page, surface charge. And the volume charge, that means a sphere that is a full of charges, that is the volume charge. For line charge, there is a one quantity, that is the rho L, line charge density. For surface charge, rho S, surface charge density. For volume, rho V, volume charge density. So how it is defined? Rho L is equal to dq that is the small amount of charge distribution for the small amount length. So it is dq by dl. Simple, you can use q by l, but as in electromagnetics, the limits are very high. So we consider first dq, that is the differential charge and differential length. So dq by dl. Okay. So calculate dq is equal to rho l into dl. Total charge calculation is equal to, remove that d and integrate over the limit for that specific length rho l dl. This is the charge calculation from the line charge density. Similarly, for rho s, differential charge divided by differential surface dq by ds, charge per unit surface area, charge per unit length. Unit for this coulomb per meter. Unit for this coulomb per meter square. So calculate dq is equal to rho s into ds. So calculate total charge, integration over the surface rho s ds. Same for volume, rho v is equal to dq by dv. dq is equal to rho v dv. Q, volume integration, rho v dv. Unit is coulomb per meter cube. That is the volume. Line charge density, surface charge density, volume charge density. Three important parameters for continuous charge distributions.